since you started, you just mentioned that you'd started as a rookie on Petronas Towers, and then now are involved in more than half of the 20 tallest buildings in the world. So what's been significantly different? This is a large enough question that you can take it wherever you want, but have you seen any major changes in how tall building design and development is done in that time? You've kind of been at like the helm of tall building design now for some decades. How has it changed?
Well, first of all, Thornton Tomasetti, our company, is fortunate enough to be able to get involved to be the engineer, structural engineer for all these high-rise buildings, starting from the Petronas Tower that we started the beginning of the super high-rise booming. Of course, Petronas Tower is the first one, and since after Petronas Tower, we started the Taipei 101, which holds the current title for a long time. And after Taipei 101, then we come to China, start to do the tallest concrete building, the Plaza 66, and after that, wow, we started the Shanghai Tower and so on. Yes, every project we see huge improvement in terms of the structural efficiency design, and also the material selections, and also having a lot of feedback with between structural engineer and architects and the wind tunnel engineers, working as a team in tandem with each other in order to achieve, and also sustainable design engineers, and also mechanical engineers, and also the contractor. Before, I think in the many years ago, basically it was very much driven by the architectural design. But right now, the design is so sophisticated. The continuous input at the early stage of design is happening between structural engineer and the architect and the mechanical engineers. And also the computer software that we are using, the state of the art, plus our own in-house software, really enhance our capability to analyze complex problems and optimize the building structures, and also taking into consideration the ease of construction and how to simplify constructions. Also, we cut down the material a lot. We can do multiple schemes to evaluate the best scheme and the most efficient scheme, and then present it back to the architect and the rest of the design team and give them what is the best solution, what's more sustainable, what is more efficient. And they only want to pay a premium for a certain architectural design, at least the data is available. In the old days, the tools are not available. Right now, the architects also have all the computer software, the Revit, the Rhino, the Grasshopper, and so on. And we do have the same thing. So it comes a long way. However, we have to watch out. The overuse of software can be a problem. So we don't want to have garbage in and garbage out.
How can overuse of software be a problem?
Well, people take it for granted. They think that the software output is correct. And sometimes they oversimplify the input and also misread the output. So it can be dangerous. So what really becomes the backbone of our advancement engineering is really the experience also. You cannot just have the right software without the right experience. And that's where with Thornton Tomasetti is so proud of that. Our experience on so many high-rise buildings and our team experience lead us to the fact that we can really deliver a win-win situation and efficient design for both the owner. So far, all our super tall towers are breaking records in terms of efficiency and cost a comparison against the others. We always bring in the home run for the owner. And also the layout. We study numerous layout, columns layout, bell truss layout, regular swivel layout, numerous layout to make this space more user-friendly.
So you mentioned efficiency. How can that sort of comprehensive building analysis lead to a more sustainable tall building?
Yeah, well, of course, the taller the building is, the more lateral wind load you have to take. The more overturning moment you have to resist. So normally, when you have taller building, your column size goes up, your shear wall sizes go up, or lateral system members goes up. It will reduce your floor area efficiency because all the structural member size will be thicker or bigger, and it will be heavier. How do we overcome it? It's through more accurate and sophisticated design. We also try to select the best structural system to fit the form and the function of the architectural design. It has to go hand in hand. The architects always want this and that, but if we advise them, give them the appropriate solution, they will consider to make adjustment in the architectural design. That will be a win-win situation. So we try to reduce the material. And also we have to deal with building codes. In Asia, especially in China, they have different building codes than what we use the IBC code in the States. So we have to understand the purpose of their code and why they're driving this kind of requirement. Some of the requirements in certain code may not be applicable to certain projects, to a specific project. So we have to use our experience and our engineering knowledge to analyze it and present the right approach to the code committees, to building department, so that we don't over-design or under-design a specific problem in order to achieve sustainable. Sustainability is the less material you use, the more sustainable the building is. And also we have to work with mechanical engineers, architects, the curtain wall designer, the orientation of the tower, and so on. All leads to the sustainable design target. So if we know that the mechanical engineers are looking for a certain mechanical system, how we adjust our structure, our building structure, our spandrel beams, our shear wall openings, our mechanical floors to accommodate them in order to achieve it. Like the full height glass, or the window shades, and with the architects, we all have to work together to achieve it. So it is an immense coordination effort among the design team in order to achieve a sustainable design.
Right, those are all the factors that influence what height a building can be called sustainable. Would you say that there's an optimum building height?
Well, I wish there is a fixed rule for that, but in reality, there's none. You can have a very tall tower. Right now, we're building, our company, Thornton Tomasetti, has been designing super tower over 1,000 meters. We still achieve very high sustainable efficiency without compromise. Even compared to a 30-story building, we outperform design with a 30-story building, even with a 1,000-meter, 150-story building. So we are confident that we still can deliver the sustainable target up to platinum level with super high-rise building, if we are careful enough and put in our hard work into it. So I don't think building height will affect our sustainable target at all. We can do it.
Let's talk about a current project, the Ping An International Finance Center. What's one thing that surprised you about working on that project, or what are some of the main contributions you think to the field of structural engineering and design?
Well, the Ping An Tower comes with a unique form and shape because it has a 4 recessed corner, and there's no corner columns because of the architectural requirement, because they want to get rid of the 4 corner columns in order to create a great architectural corner entrance. So when we lost that corner entrance, we don't want to cantilever over cantilever the building structures that much. So we introduced some kind of diagonals, at the from each side to pick up the floor structure. So suddenly, when we have this system, we say, wait a minute, we look at the architectural forms and shapes. So, and we also look at the structural requirement, because we have to design for earthquake, for Ping An as well, and also for lateral high typhoon wind load. So we took advantage of that situation, and then we work with the architect and say, can we have the continuation of the corner diagonals at each corner of the building? Can we put some huge mega bracing outside, because this is an office building. They can manage the office layout very well. So basically, we introduce some non-intrusive super diagonal bracing on the exterior of the building that works in tandem, hands in hand with the architectural setup they have at the corner, and it fits in very well. So that structural system basically blend into the architectural design and achieve efficiency. And in turn, when we have the exterior bracing, we lighten up the shear wall, the core of the tower, the concrete shear wall, make it lighter, make it thinner, make it less reinforcement, and also the outrigger that connects to the super column. So we make the column size smaller, the super column size smaller, the outrigger smaller. So one thing leads to the other. It was really a win-win situation. And also Ping An is a high typhoon window. With the notch corner, we cut down the vortex shedding, which may cause dynamic resonance for the building. So it cuts down the vortex shedding with the re-entrant corner. We even, the architect working with architect and the wind tunnel test consultant, we tapered the building in order to reduce wind load at the top, in order to make the building the Ping An Tower, a lot more aerodynamic, in order to reduce wind load and also reduce vortex shedding and make the building much more lighter than the other building. So it's one of the lightest superstructure that the others are designing. It's one of the lightest building. And we still can get the building expert approval in China after they examine intensively our design. And they give us a very quick approval on that project. So we have a happy owner and a happy architect on this project.
That's interesting that it's a perfect synthesis of engineering, design, and then even the owner's specifications there.
Yeah.
That leads me to ask if you could select a major tall building design, operation, or management topic that still needed research, or that was badly in need of some innovation. What do you think is one of those topics?
I think there's still one of the topic I still want to enhance is that how do we bring earthquake design into building most of the high-rise building in a more unified format? Because I think earthquake is subjected to what kind of seismic force, what kind of response spectrum, and what kind of time history seismic curve you have to design to. You know, seismic you can only estimate based on previous history. So and the building code in different area subject you to a different seismic force requirement. I think more research should be done into that area in order to bring the seismic design criteria, which affects all our tower design in the near future tremendously. Because right now we know that earthquake is happening more and more often. We have to deal with that. Fortunately, most of all the high-rise buildings are designed for seismic. How do we pay more attention to seismic design? Because when the earthquake hits, it can be dangerous to the occupants. But still, engineering-wise, we're capable to handle it. We're paying good attention to the seismic design. The other thing is building deflections, building movement and acceleration. On super high-rise building, we try not to make the building too stiff by dumping a lot of, wasting a lot of materials, construction material into it. We try to use a lot of dampers. There are all kinds of dampers. There are viscous dampers, there are active dampers, passive dampers, and there are also the buckling resisting bracing dampers. There are all kinds of dampers, and or base isolation dampers. So more new technologies are really available for us to use this, I call it the good equipment that we can employ. So I encourage my colleagues and even ourselves try to study more. And hopefully the owner will support us, because by using all these dampers, we have to do a lot more work and more analysis. And it's a cost issue for us, and if we get more support from everybody, we can do more research and more detailed work into this field.
And make the building last longer.
Exactly. We try to design a Ferrari. You know, we can. I mean, doesn't mean you can only sit 2 people. You can sit 50,000 people in the building, but it's very efficient. Okay. I think more high tech will be going into every building. We're in the era of smart building now. Definitely, with the tools we are available, plus the experience the companies, our company and all the other colleagues, other company are gaining in high-rise building. I think there will be a lot more interesting building coming to society, especially architects can design so many interesting, beautiful buildings nowadays.
How do you define a smart building era, as you just put it?
I think smart building era is not only structural. It has to do structural, which I described. We can do all the optimization, do all the damping, the system, do the analysis, use the best connection, and also use all the all kinds of detailing for the connections, prefabricate some certain component. But now the smart building can be automated, the mechanical engineering and automate everything. And right now, we have light sensors that dims the light. We have automatic curtain that will reflect the sunlight, the climate control, the safety control, the fire control, the elevator control. Everything are working together into the building with the architect. You know, the curtain wall, the glass window. I think that everything is part of the smart building components into it. And also even the maintenance, okay? Well, I'm not surprised many years later, very soon we may have a robotic window washing system, right? You want to see the beautiful clean building, you need a robotic BMU system. So I think to building industry, sky is the limit. We're excited about it.
To that point, we only have a couple minutes left, but I wanted to ask you if you had thoughts on how tall or how many floors the world's tallest building will be in 2050 and why.
2050, I mean, our company, Thornton Tomasetti, have designed many super high-rise before and studied many high-rise before that is still on the shelf. We did a mile-tall building design before in the Middle East, but it was shelved because of the economic situation many years ago. I'm not surprised. We can definitely get the mile-tall building built.
Do you think we will?
I think so, because I think that's the next milestone. We have the 1 kilometer tower already, so the next one will be a mile-tall building, as long as we have the support with the developers, the society, and the motivation to challenge ourselves. It will be fun. It's a vertical urbanization. It doesn't mean that it will be eyesore, because a vertical city saves a lot of space, and people enjoy living in different heights, and we can have roof gardens and all the amenities above. We don't have to go down. We free up a lot of ground space for other use, as long as you have the right master planning for the city. So I think I want to see it, and I'm ready to design a mile-tall building, which we have done studies a lot before. So I hope I will see you next time to talk about a mile-tall building.
Me too.
Our company and our team will be have the opportunity to work on.
Yeah, well,
we just have to find the developers.
Yes.
The right here. Yeah, the sky is the limit.